So these are the worst lectures, I swear. Because homework's due. I'm ready to talk about authentication. Y'all are talking about what I was talking about for the last 3 weeks. I'm done talking about that stuff. I don't want to talk about WebSockets anymore. But yeah, it is a joke. I'll ask for questions about the homework. I'll spend some time on it. But for homework 4, after today's lecture, you'll be able to do through objective 4 on the next homework. So the next 2 weeks of content are just talking about that objective 5, very similar to the current, I should say, homework, where I talked about WebSockets first, and then the rest of the content, like a whole week of content, or 2 weeks, I guess, was just talking about WebRTC and then applications and practical tutorials and things like that. So I might as well do this right now. Anybody have questions on homework 3 that they want to talk about? There were a few common things I saw in office hours on Wednesday. I guess I shouldn't say a few. There's one that comes to mind. Sometimes when you're reading for objective 5, hopefully a lot of you are on that objective, when you're reading from the TCP socket, from the WebSocket, sometimes you'll get multiple frames in one read from the TCP socket. This is something I'll officially put on the homework next semester, make sure everybody's aware of it and whatnot. But sometimes the client is sending multiple candidates, like basically back to back, fast enough that they're both read from the TCP socket at the same time. So it's something to look out for. You should be able to handle that. You should be handling that, where if you read the payload length, then the next number of bytes, whatever the payload length is you read that many bytes, and that's that message. If there's still more bytes that you read from the TCP socket beyond that payload, that's the start of another WebSocket message. And this is perfectly valid for sending messages too. Well, that doesn't work. But if somebody sends 2 messages very quickly, or probably the only way to get it fast enough would be in their JavaScript, or if they have a little network delay, they send 2 messages and the network's hanging, and then all of a sudden the network sends both messages, you'll get both of those messages in one read from the TCP socket. So this is something that should be handled. When you read the payload length, only read that many bytes. And make sure you read that many bytes. So you have to buffer, but you also have to make sure you don't overshoot your target. You don't overshoot your payload length. For what it's worth, I didn't run into that when I was making my solutions. So you might not even face that issue. But it's one of those things where if the grader finds that issue, I got to make some decisions. Probably just wash it and give you the 3 if that's your only issue. But if you're banging your head against your code trying to figure out what's working, just be aware that that could be an issue that you're facing. If that's the only issue with your code, I think I'd still give you the 3 if we can isolate that is the only issue, which, just be aware that the burden of proof might be on you for that, because it would take a long time to do that for every student in the class. So just something to be aware of. Next semester, they're going to be required to handle that, though. But it's a little unfair because I didn't cover it in lecture. But that was the idea of confining WebRTC to one objective, because realistically, it should be 2 objectives, and you should be doing more with it instead of just forwarding the messages. I wanted to keep it as light as possible this semester so we can identify what all the issues are going to be, and then I can bulk it up next semester. So I want to be a little easy on the grading for it, too. But your WebSockets better work. WebSockets themselves with chat, as long as we send chat messages slow enough, you won't run into that specific problem. So your chat should be working. Do we need to allow the WebRTC to work over separate browsers, or will it only work over the same browser? You might be the one who asked me this earlier. I had somebody ask me this during office hours. And if it works in the same browser, I'd say we'd have to give you the points, because I don't fully know what could be causing that. I had a student, you might be seeing the same issue, or you might be the same student, where 2 Firefox tabs works great. 2 Chrome tabs works great. 1 Chrome tab and 1 Firefox tab doesn't work at all. And I don't know, that's just wild. For WebRTC, we're going to give you the points, but I want to investigate further to see what's going on with that. Yeah, I'll talk to the TAs, we're not going to test with that, because a few students saw it and I don't know what's going on. I swear I tested my code like that, but I'll take a look at that. I got to dig deeper for next semester, at least. It says it doesn't recognize my computer's camera across browsers. Oh yeah, that was my guess of what was going on. But somebody said it does work, and somebody just now said it did. Actually, I think you might have been the same one who said it did during office hours. That I think the browsers are fighting for control over your camera. So once one has access, the other one's getting blocked. I think that's what's happening, but it's weird that's happening on some people's machines and not others. Maybe it's different operating systems that don't lock it down. But at any rate, we're only going to test with one browser. Because it wouldn't make sense for two browsers to share the same webcam. Like, in the real world, that's never going to happen anyway. Like, that doesn't make sense. It works on my browser. Yeah, you need two webcams. Get a USB webcam. That wouldn't be a bad idea for the TAs to do testing with. Not this semester. It is what it is. It will just be we'll be pretty soft on the grading of Objective 5 specifically, just because I wanted to keep Objective 5 simple enough, just forwarding messages, and we can identify all the WebRTC specific issues. Unfortunately, it's just something that happens when everybody's using different browsers, different OSs, different versions of everything. I get to put an assignment out there and figure out everything that's going to break. There's always so much stuff in this class. So I like to introduce new topics very slowly, like that. As you can imagine, the first semester was absolute hell for everybody. Do we have to deal with share screen? Oh. No. Right? Like sharing your screen instead of like a virtual camera? I would imagine that would work the same, but no, we're not going to test for that. Of course, I would imagine working in different browsers would have worked the same too, so I don't know. But like if you set up a virtual camera in OBS and share that, I would imagine it'd work just the same though. I don't think the browser cares that it's coming from a virtual camera or a real camera. Did you test it and it didn't work? Or have two OBS virtual cameras and share them with each other. Yeah, if somebody tests that and it doesn't work, I'd like to know about it. I want to gather all the information I can about this. Was the only questions about homework 3? I thought there'd be a lot more. Any reason why a large message sent over a WebSocket connection works the first time but doesn't on a second large message? (64-bit). Yes, I'm trying to wonder if you're I think a student talked to me about both these. I wonder if you're the same one. If you didn't solve them yet. But I did see someone with this issue. It would work with one large message, but not another. And it was an issue. Well, I found what I thought was the issue, but the student didn't come back. So I don't know if that resolved the issue. But it was in their buffering code. Make sure you're buffering and only reading. Make sure you're counting the bytes that you're reading properly. The code that I've seen this quite a few times from quite a few different students, of reading, calling receive with 1024 or whatever value you have. Most people have 1024 because that's just what the default is. That's what the documentation has, so we all kind of just stuck with that. Reading 1024, or calling receive with the value 1024, and then assuming that you've read 1024 bytes. That is not necessarily a true assumption. It's up to 1024 bytes. So if you're saying, okay, I've read 1024 bytes because I called receive with 1024, that can cause issues, which could cause this issue as well, if the messages line up like just right. If you have a little extra information on the TCP socket, or more likely in this situation, you have some extra information, or you've read more information. Actually, I keep running in circles with this one. You read more information than you needed. I forget. I had this figured out on Wednesday, but I kept going around in circles on what it was. But make sure you're buffering and counting your bytes properly is one thing I can say about that. So when you call receive, check the length of the stuff that you've received. That's how much you've actually read. Don't assume that you've read a full 1024, is the short answer to that. How do we set up a video connection on 2 different devices instead of 2 on the same local host? Good question. Talk to me next week. We'll talk all about that. So WebRTC doesn't work over an unencrypted connection unless it's localhost. So you can only test on localhost if we're unencrypted. So next week, when we talk about encryption and HTTPS, we'll be able to create WebRTC connections across multiple devices. But until we have HTTPS, the browser's not going to allow that connection. It's just not going to do it. It's not going to make an unencrypted connection for WebRTC. The browser will block it. I think only Chrome has this problem. I've lost track of what problem you're talking about. Firefox, bless you. Firefox accepts multiple large-sized messages, so I think it's not a coding problem, but Chrome does do silly things with buffers. So the way Chrome sends messages might be messing with your buffer code. And it's not necessarily, I hear that a lot in this class. If it works in one browser and not the other, therefore it's not a coding problem. My code's fine because it works in Firefox, or my code's fine because it works in Chrome. That's not necessarily true. If you implement your server improperly, you don't exactly follow the protocols, different browsers will have different ways of possibly forgiving your mistake or checking for your mistake and just assuming what you actually meant. And different browsers will do that in different ways. If you follow the protocol exactly, your stuff should work in every browser. But if it doesn't work in a browser, it's almost always a coding error. And one of the browsers, whatever browser it works in, just happens to see your coding error and fix it in some way. Or, like I first mentioned, maybe Firefox, just the way it sends data doesn't hit your issues. There's a wide variety of things that can happen, why it works in one browser and the other browser. But almost always, very rarely will this not be the case. It almost always will be that you didn't code the protocol exactly the way it's intended to work. Very rare cases. The one rare case that I always mention is a redirect in Firefox doesn't work unless you have a content length of 0 for some reason. I maintain that Firefox is in the wrong on that one. But other than that, I'm not aware of anything where you can follow the protocol exactly and it doesn't work in a particular browser. All right, any other homework 3 questions? Or did I miss anything in there? You can repost if I missed something. That would have a lot more homework 3 questions. I'm more than happy to have fewer. I assume all the other questions are just like specific coding questions and you can't ask during lecture, is what I'll assume. And multiple large messages. It's the second time I'm hearing that. I'd like to know what the issue is when you do find it. But it's got to be a buffering issue. I don't see what else it would be. All right, let's talk about tokens. Authentication tokens specifically. So I don't have very many slides on this. There's not a whole lot I really need to say, and then the rest of the class will be the rest of the lecture will be demos, or I'll just go to your questions, since I think that's what you want to see. And I can always do the demos over the next 2 weeks. We have some slack in the schedule. Like in 2 weeks, it's, what do I even have on the schedule? Architecture, Docker, Nginx, Docker deployment, and everything. These are fun lectures, but we can fit extra demos in here. In reverse, didn't I update this? I did not. I wanted to put reverse proxy servers in this week. But anyway, there's room to do those demos if we want to talk about homework 3 some more. So authentication, we've talked about this. We know about this. You register, here's my username and password. You authenticate, here's my username and password again. And if this password that they use to authenticate or log in, authenticate's our fancy word for for logging in. I mean, there is a difference, but I probably should just explain the difference since I mentioned it. Authentication is authenticating if this person is the person that they claim to be. When you send your username and password, you're saying, I am claiming to be this username. And authenticating is verifying, are they actually that username? So that's authentication. Logging in is when we're issuing that auth token, which we're talking about today, and then they're actually logged into the service. Or if it's a non-web application, login can mean something different. Logging into my computer, that's a different thing. It's not necessarily an auth token. But that's the login process. Once I'm logged in, that's different than authentication. Authentication is part of the login process. Authentication is the verification part. So when they register, we take this password. We're not doing this semester. I had this set up as an objective, but I cut it this semester. I don't know if you learned anything from it, but checking the strength of a password, that should always be done server side. This is the key part that I want to mention. It's not really worth having a whole homework objective on it. So is this password, we could use the standard criteria, 8 characters, does it contain a lowercase and uppercase, number, and a special character? If it does, then allow it as a password and have them send 2 passwords, make sure they match, doing all that stuff. It's just tedious because once you do that objective, every time you test on your front end, you got to type in a valid password. So you tend to remove those requirements while you're testing and then add them back in for submission. And then you forget to add them back in when you submit to Autolab. And I just don't like the requirement. When you deploy in the real world, absolutely validate the strength of a password. Make sure they verify their password by typing it twice to make sure they didn't mistype and now they can't log in, all that kind of stuff. But the key part that I do want to say about this is those checks must be made server-side. Hopefully I've made this point enough throughout the semester that you can't trust the client. If you set up all kinds of password strength verification on the front end and say, don't send the registration request unless these criteria are met, and you write some JavaScript to make all those checks, and then submit, and then on the server side say, well, I got all that front-end code that checks the strength of these passwords, so I'm going to assume that they're strong passwords. Do not do that. You must verify that on the server side, because on the client side, somebody can just go to that JavaScript and delete it all. Like we can find that verification code, because that does exist. Like you've seen front-end code that verifies passwords. That does exist, where you type in your password and dynamically the check marks show up. Okay, you've met all the criteria, you can submit now. But you can still submit without passing those criteria. You just go to their JavaScript, delete some things, or just make the AJAX request directly to be able to register. People can do that, and they can submit insecure passwords. Now, there's not too much harm here because they're only attacking themselves. Like, what's the point? But you could have some users who will submit insecure passwords. And if you want to protect them, or you better protect them, have something client-side or server-side that's going to double-check that. So when there is front-end password strength verification, there's always also, or there should be, there better be anyway, server-side password strength verification as well. Yeah?
So when a user sends in their unique password to the server, technically you can read their password. Obviously relevant, right, to verify it.
Yep.
So basically we're just trusting all these companies that they're not storing our passwords somewhere.
Yes. Yes, absolutely. And that's something I'll demo next week. Like your passwords are being sent to the servers in plain text. I'll do it during lecture next week, but you can do this right now. Go to any site ever where you can log in, where you log in with the username and password, and open up the console, go to the network tab, and then submit your username and password. That password will be plain text. Like any site you go to any site. If you find one that doesn't do this, let me know. And I can use it as a lecture example. I found one in all my years of doing that and just going to random sites during lecture. I'll say, call out a site, whatever site, and I'll go there and it'll be plain text.
Is there a workaround for that?
Nope.
It's not
Yeah, it's not really. So you can hash client side, but it doesn't have any benefits. And it has the downside of you can't verify the strength of the password. So if you're hashing, the TLDR on this is, like you could hash client side and then send only the hash. but that hash is effectively your password now. If somebody has that hash, they can log in as you with that hash. It's the same thing. So might as well send the raw password and then verify the strength of the password. But it's all plain text. That's where encryption comes in. So luckily that's encrypted, so people can't actually read your password. But we are trusting the server. We are trusting the company who's handling our plain text password. We are trusting them to actually store it securely. That's just a fact of life, unfortunately. So when you're going to some, like the big companies, you don't have to worry about too much because they're not going to risk that kind of exposure. Like we kind of have some sort of a safety net there, but like smaller companies or privately owned, small businesses that might have just hired a developer to throw together a website over a weekend, they might not be. You do have to just trust them. So it's something to think about, that they might not be storing your password securely. And that can get scary. So authentication, okay, here's my username and password. I rushed this a little bit last lecture. When you store the password, you're never storing it in plain text, as we were just discussing here. You're not just hashing it either. You're going to salt it and hash it. So you're generating a random string that's going to be the salt, appending that to the password, and then hashing the password and salt together. And then in the database, you're going to store that hash, that salted hash, and the salt. The salt is in plain text. So the salt doesn't add any security necessarily, or it doesn't add any entropy, because the attacker has that salt. They can just generate their random guess, append the salt, and then guess it. Hash it, and then check if the hashes match. Take another guess, append the salt. They can just do that. It's no big deal for an attacker to do that. So it doesn't add any entropy. The brute force attack still takes the same amount of time. A dictionary attack takes the same amount of time. But those rainbow tables are useless. We get rid of those rainbow table attacks because that salt does not exist in the vast majority of the guesses that are coded in those chains. Those chains are just worthless at that point. So we salt to get rid of those rainbow table attacks. If you're not salting and an attacker realizes that you're not salting, holy crap, they're going to dust off their rainbow tables and go to town on all of your users. They're going to crack all those passwords pretty quick. Make sure you're salting those passwords. So when we get this username and password that somebody's trying to authenticate, go to the database for that username, get that hash and salt, append the salt to the password that they just gave you, hash it, and then check if the hashes match. If the hashes match, they're authenticated. If they don't, they're not authenticated. Okay, so once they are authenticated, somebody's logging in, we go to the database, pull the data for that username, pull the salt, append, hash. Everything looks fine. Okay, now we're ready to log this user in. To log a user in, we're going to generate a random token, which should have at least 2 to the 80 bits of entropy. If you're generating a random hex value, 2 to the 80, the math is pretty easy here. Just make sure it's at least 80 bits or 10 bytes. Create a string at least that long so it's what we call secure, what we're comfortable with, or make it longer. More secure is always fine. And then assign that token to this user. That's going to be their authentication token. Now, whenever you see that token, I'm getting ahead of my slides. And then associate that token with the user. Whenever I say something like this, associate this thing with this thing, associate this token, this auth token with this user, what I mean is throw that in your database somewhere. Somewhere in your database, you should say this username, this token. So when you see that token again, you can go to that database and say, select star where token equals this token I just got, and see if it matches any usernames, and read that username that is associated with that token. So associate this token with the user, throw it in the database. You can throw this right in your user's database. We can assume, for this homework at least, for homework 4, that each user is only logged in on one device at a time. So if you just have in the user table, username, hashed and salted password, and authentication token, and just have one token for each user, that's fine for this homework. Now, realistically, you would have multiple for each user, and you can implement that. I'm not going to stop you, but for the testing procedures, we're not going to have the same person log on and two different browsers. So once we have this, this token, we're going to set it as a cookie. So we're going to say, hey, user, here's your cookie, which should have for our purposes, the HTTP only directive. We can't do the secure directive because we don't have HTTPS yet. Again, maybe next semester I'll have students do add secure to their token, but not required this semester. And in real life, you better add the secure directive. So once we set that, we have that token associated with the user, we set it as a cookie, and then whenever we get another request, and whenever we get a request from anybody, we're going to check if that cookie exists and name it, something you can get, auth token would be fine. Read that cookie, check its value. If it exists, then look up in your database and say, hey, is this a valid token? And if so, who is this associated with? So select star where auth token equals this token that I just read from the cookie, or find, and then your dictionary, your lookup dictionary, auth token, this token value. And if you get any results from that database, then you know who this user is. You can look up who that user is. Okay, I issued this token to this user. If you have this token with so much entropy that nobody could possibly guess it before the sun burns out, then you must be this person. Like, you have to be. So you're going to trust that is that person if they have that auth token. So anybody who possesses this token, we're going to verify that they must have been authenticated in the past. So we're not checking their username and password again. We're just saying, you possess this token. I gave this token to this username. Therefore, you must be this person. So that's the level of security we have with these auth tokens, which isn't 100%. It's not guaranteed. There's no guarantee that the person who possesses that token actually knows this username's password. I guess that's true in a lot of cases. I'll be logged into some places so long I forget my password, but I still got that token set as a cookie, so I can still log in. So even with legitimate users, that's not always true. But if they possess the token, we're going to verify them and treat them as logged in, and then serve content for that specific user. So these tokens are as sensitive as passwords. If somebody has a token, they can log in as that person, just as if they had their password, they can log in as that person. They're just as sensitive as passwords, maybe more so, maybe less so, depending on which angle you look at it at. But these need to be secured. You can't have a database sitting there just filled with these tokens and usernames. This username, this token, this username, this token. Somebody attacks that database, they just take those tokens, and they can just be any user that they want without even knowing their password, without having to crack a password or anything. So hash these things. Only store hashes of these tokens. This is a security thing listed on the homework. Again, whenever you're doing the homework, those of you submitting homework 3 tonight, make sure you're going through, do some last minute checks, and make sure that you hit all those security things. I highlight them in red, bold text, so you can't miss them. They're in the instructions and the testing procedures. Please double check those. It's not fun. After grades are released, the handful of students who come to me and say, I spent hours and hours of my life on this homework and I got a 0 on these objectives because I didn't do a security thing. It says security issue. All that time is wasted for the multi-part form especially, because objective 2 is the bulk of the work. Bless you. Objective 2 is the bulk of the work, but if you didn't escape HTML, that's a 0 on objective 1 and 2 that you just spent 10, 20 hours of your life doing. Please double check these. It doesn't take long to double check to make sure that you hit all these security things, but it's not something that can be allowed. If I need to stress the importance of security. I've said this many times. I'll say at least once more here. If you build a pretty crappy website, like out there in industry, you build a pretty crappy website, but it's secure, that's okay. There's room for improvement, of course, but it's not the worst thing. But if you can build the best, top-of-the-line, state-of-the-art, best user experience anybody's ever seen on the planet website for a company, and it has a security vulnerability in it, well, you might be getting fired. That's terrible. That's horrible. That company's could make, if they're big enough, they're going to make headlines. You're at the very least not going to have as prominent of a future as you would like, and you possibly would lose that position and have a tough time finding a new position. Having an insecure website out there can be absolutely disastrous. Yes?
Can you say,
Yep. Mhm. And I recommend, it was really quick at the end of the last lecture, but I recommend using bcrypt for that. You can use this library, and in like 2 lines of code, it'll do everything. 1 line of code to generate the salt and hash it and store the hash and salt together, and then 1 line to verify a new plain text password with that hash. Super straightforward. It's very, very easy to use. I may or may not do a demo on that. I think I want to leave that to, hey, use bcrypt, and then you got to go find the documentation. But it's simple. It's an easy documentation lookup. It has a gen salt method and a generate hash method that takes a salt as a parameter. So you can do it all in 1 line. Yep. Yeah, and what it spits out when you hash, it'll just be one big hex string looking thing to us. But what it has is the salt and the hash all in 1 value. So you only have 1 thing that you need to store in your database, and it has both those values that we need. So when you want to authenticate someone, you just pull that big thing from your database, throw it into bcrypt, call check password. It takes a plain text and that big thing that contains the salt and the hash, and bcrypt just says you're good or no. So it's very simple to use that library. And I don't want to set the standard or set the impression that you should be doing your own hashing and stuff. Just use the library. bcrypt is industry standard at this point. Just use that library, and it'll take care of the security stuff of generating the hashes for you. And it has all kinds of other features too. I believe it has a generate token feature. You can generate long random tokens too. So only store hashes of these tokens. The salt isn't necessary if you're generating tokens with at least 80 bits of entropy. The salt isn't going to add to that. It doesn't matter. Salts don't matter. Even without the salt, like you can add a salt if you want, but even without a salt, those rainbow tables are useless because 2 to the 80 is just such an extraordinarily large number that rainbow tables really aren't going to touch it. And again, if you're worried about it, salt them. If you're still worried about it, generate 200-bit long tokens. Like, there's no harm in that. But at least 80 bits and no salt required. So for the homework, storing those salted hashed passwords and hashed tokens, or optionally salt them if you want. So we're going to read. I went over all this, didn't I? I guess, is it worth going over again? Do you all get the idea at this point? Let's just store their password in a cookie. I mean, no, but kind of. Oh, I missed a lot. Here. Yeah, the 8 characters. Don't actually use, you know what, let me just go into the demos. So someone can hijack your cookies. So this is when we're talking about JavaScript attacks, when we're talking about HTML injection, and one of the things I said, well, they can inject JavaScript and they might steal your cookies, and it's all bad news after that. One, we have the HTTP only directive set on our tokens, so that should mitigate those attacks, but it's possible that you are logged in at 1 or more sites that don't set that directive, and you might be vulnerable to those attacks. Again, probably not the big name sites that have huge teams of engineers. Like, at least one person on that team at one point in time said, hey, we really got to be setting that directive, guys. And then they said, yeah, let's do that. But lesser known sites, maybe. Do the tokens need to expire after some time? Every cookie needs an expiration date. When you look at the actual expiration dates of your cookies, I'm going to go to a specific site here. Site that's kind of dead these days. I didn't even have in my history. But if I typed that wrong, didn't I? If I go to this site, I can see I'm logged in. I don't even know if I remember my password on this site. But if I go to the network tab, I'll refresh this thing, and I'll see that privacy policy was the first thing. Where's the... I mean, all of these will have them, I guess, but not that one. Is the top one the privacy policy consent? Oh, yeah, it is. With my username in the URL. Yeah, it's a redirect. It's a redirect to a URL with my, where's the location, with my username. That's, I don't know if I've actually seen that before, username. Maybe I haven't been paying enough attention. Obviously, because I've been to this site before and I haven't noticed that. But we can see in my requests, if I can find the right place, request headers, I'm going to have some cookies. And I'm going to have a lot of cookies. Most sites you go to, you're going to see a lot of cookies in this header. But they're going to be semicolon separated cookies. And I'm going to have, a good number of cookies. If I go to application and read those cookies, I can read them in a little more readable format. It's going to parse them on semicolons and give them in a better format for me. So I can see some of these cookies. Congregate session, my session token. These will exist even whether you're logged in or not. You'll have some session token to remember this specific user. And this Kong sec, this is going to be my auth token. So if you take that token, I should be careful with that one and not let you have that token. Now, it's Congregate, so I don't care that much. That's why I use this site. But if I open up another tab, oh no, I don't have Google. I don't have Chrome installed on this, do I? I don't think I do. No. All right. Well, I'll have to use another. Opera window. I was going to use Chrome, but I don't have it installed. Congregate. So if I go to Congregate, let me inspect element. Application, look at my cookies. Actually have quite a few. I'm going to delete those cookies. I thought there was a delete all cookies button. I'm going to refresh. Now I'm in a private window, and you can see all these cookies that are set. You can see that I still have that session token. So that session is still set, even though I'm in a private browser window, I'm still being tracked. Like, I'm not actually private. Private browsing doesn't mean you're browsing privately. Don't make that misconception. Private browsing means that your local history isn't being stored, so somebody else who shares a machine with you can't see your browser history. So when you live with somebody and you don't want them knowing what you were browsing, that's what private browsing is for. It doesn't make you private to the rest of the world. So just be aware of that. There's some things the browsers do to try to keep it a little private, but not really. Like, Opera's not deleting this session token for me. And if I go over here, I know this Kong sec and I believe Kong svid are my authentication tokens. And obviously I'm not logged in here. I didn't log in. But if I add a new token, I grab this value, svid, and I want to grab this value too. I'm pretty sure, oh, that's a GUID. What am I looking at? Oh, I'm looking at the wrong one anyway. I want these ones that don't expire. So all cookies, that's the question I wanted to answer. All cookies have to expire, but when it's an auth token, just have it expire in like 2042. It's effectively not going to expire. So I want to grab this value. All these ones that don't expire, I want to set these. So the svid, I want to replace that. Guess secured visit recorder, probably www.pass. Sounds like it's authentication. Let's see if that does it. Let's refresh this page. Let's steal the session too. Maybe they have something to check the session. And I'm logged in as me. So I didn't type any password in. I didn't do anything special here. I just hijacked those cookies, set those auth tokens to the values that I want, the values of my logged in session. And the server is going to say, oh, if you have those tokens, you must be this user. You have to be. There's no other choice. There's no other choice. You have to be that user. So I'm treated as that user. Because they're not checking my username and password. They have no way of checking if I've logged in the past. HTTP is stateless. They can't check that. They just check, do you possess that auth token that we set as a cookie? If yes, you are that person. And I can access my cookies, even though these are HTTP only, and this one's secure. Like, I can't read those in JavaScript, so somebody will have a hard time hijacking them through a JavaScript injection attack. But if they have access to my laptop, they have access to all of my auth tokens. They can log in anywhere as me without having to get my password. They just grab the token values that they want, and they are me. They can be me. And these session tokens, if I close the browser and open it back up, well, it doesn't work in private browsing because it'll wipe them all. But those session tokens are the length of the session of the browser window. Oh yeah, and if you're talking about the homework, the tokens need to expire in longer than an hour. That's explained in the document. They should last for an hour. An hour gives us enough time that a TA won't be grading your specific assignment for more than an hour. So an hour just gives us plenty of time to grade. If it takes an hour per student, oh man, you won't get grades out on time. All right. Do we really have time to do anything? I don't know if we have time to do this justice. At least do this much. If I use this code and hash the word password, I'm going to compute the hash of password with an empty salt. Did it run? Is it running? I'll get this value. Oops, of course I did. It's not incriminating here, right? Okay. I don't have to edit that video. And I go to my online. Yeah, that's what I thought. Oh, I don't feel like doing that. All right, I don't want to go down that road. I'm base 64 encoding this, but this, you have to just trust me on this one then, I guess. This value, base 64 encoded, should be exactly this value. My point here, the point I want to make, I'll just tell you. SHA-256, the hashing algorithm, the one that I'm using here in Java, both in Java and on the online calculator, no matter what language you're using to implement SHA-256, that is a well-defined hash algorithm, a hash function. So no matter where you're using it, it has to generate the same exact values in all places. It can't generate a different value in a different code in different places. So if you're using SHA-256 to hash your passwords and you're storing them in a database, the attackers also have that same algorithm. The algorithm is the same no matter where you're going, no matter what code you're using. Any library that implements it, any language that implements it, has to do it the same way. So they're going to run some attack code. They're going to take your hash, and they're just going to guess all kinds of guesses. Each time they make a guess, they'll append your salt to it, and eventually guess your password. Like here, I'm guessing every possible string. Let's do this and then go. Yeah, if they have your laptop, yeah, if you're saving your passwords in your browser, they have all your passwords anyway. But even if you're using a password manager and not storing them in your browser, and that password manager is locked down, they can still grab your cookies. Yes. Oh, yes. Thank you. Thank you for reminding me. So we have this one, and Wednesdays is still open. I did update the due date. This is Wednesday's lecture question. So I did update the due date for Wednesdays, so it's still open until 10 more minutes. So this is Wednesday's lecture question. Don't submit this for today's. Wednesday's lecture question. And then I can go back to Friday's lecture question in a second once we have this. Wednesday's lecture question. Everyone good on this? Anyone need more time with Wednesday's lecture question? No? Today's lecture question. This is today's lecture question. I forgot about that. I should have done that at the beginning of lecture. Done Wednesdays at the beginning and today's at the end. Yeah, if somebody has access to your device, you're screwed. Password lock your device. So it'd have to be unlocked. So if you have a password on it to unlock the device itself, then you're better off. You're much more secure. All right. Anyone need more time on this lecture question? You waiting for Wednesdays? Anyone need to go back to Wednesdays? Everyone's still doing this one? This is all I got, so you're good to go after this, after you submit. And have a great weekend. I'll see you Monday.